asking me to conduct this exam for Mr. Sai Sunil. I have just gone through his thesis also and make some comments. I hope he has addressed all these comments, and now we will start the evaluation process. I hope within a half an hour we will just complete this process. Uh, Sunil, you have to complete on your side within half an hour. Then for half an hour we'll have the questionnaire and other kind of things.
Good morning, sir.
Yes, yes, sir. Just I will give intro, sir. Then we will start, sir. Just I will give one more intro.
Yeah, yeah.
Yeah, yeah, sir. Thank you. So good morning to all. Today we are here to witness the public voice examination of Mr. Sai Sunil under the topic of optimized hyper feature selection algorithm for primary user detection in spectrum sensing. I would like to express my gratitude to Founder Chancellor Dr. Rangarajan sir and Founders Chancellor Dr. Sagunthala Rangarajan ma'am and all the higher authorities in this great occasion. I extend the warm greetings to Dean SOEC Dr. Jayashankar sir, Head of the Department Dr. P. Estarani ma'am, and all the faculties, research scholars, and professors from other institutions. Today we have Dr. Surendra Soni, Associate Professor from NIT Hamirpur, to act as an Indian examiner. I would like to say a few words about him. Sir received his BTech and PhD from NIT Hamirpur and MTech from Punjab Engineering College, Chandigarh. Nearly 25 years of experience in academic area. His area of interest is in wireless communication, image processing. Sir received funds from various funding agencies like DRDO, MOD, MHRD, and TechUp. I'm very happy to welcome you, sir.
Thank you, ma'am.
Thank you, sir. Dr. Ashraf, Associate Professor from NIT Silchar, will act as a subject expert. Sir did his BTech and MTech in University of Calcutta and PhD in IIT Kharagpur. His research areas are wireless sensor networks, wireless communication for 5G and 6G, and satellite communication. He has 15 years of academic experience. Recently, Sir completed his DST Serve funded project under the title of Impact of Error Control Code on Characteristics Distance for Underwater Wireless Sensor Network using MOCO model. He received many awards from reputed organizations. I welcome you, sir.
Thank you, madam. Okay, thank you.
In this occasion, I especially say thanks to the external examiner Dr. M. Manihandan, Associate Professor MIT Chennai, and internal examiner Dr. Ligbal sir for their continuous guidance. Now I would like to introduce the PhD candidate Sai Sunil, who is going to defend him for the PhD Viva's examination. Currently, he is working as an assistant professor in Sri Padmavati Mahila, Tirupati. He published one SCI, two Scopus and one non-Scopus, and one SCI paper under review. Now I request Sai Sunil to present the thesis. Sunil, don't take much more time. The maximum 45 minutes. Please try to complete it.
Thank you, madam. Thank you very much, madam. Good morning to one and all. Those who are attending my PhD by voice meeting today. Welcome you all. My PhD thesis title is Optimized Hybrid Feature Selection Algorithm for Primary User Detection in Spectrum Sensing. This research work done under the guidance of Dr. Shyam, Professor in EC Department, Beltech, Rangarajan, Dr. Sagunthala, R&D Institute of Science and Technology. Today's public Viva voice meeting examiners, Indian examiner Dr. Surendra Soni sir, Associate Professor in EC, NIT Hamirpur, and expert member is Dr. Ashraf Hussain sir, Associate Professor ECE in NIT Silchar, and foreign examiner Dr. S. Hussaini Mosawajjar, Professor in Electrical and Computer Engineering, Idaho State University, USA, and my total research. Continuing research, the research advisory committee members are external expert Dr. Manikandan sir, Associate Professor, Department of ECE, MIT Chennai, and internal expert Dr. Majher Iqbal sir, Professor ECE in Beltech. Welcome to the examiners and RAC committee members and professors and my colleagues and research scholars. The main objectives of my throughout research is, first one is to design and enhance dynamically threshold-based selection of spectrum sensing among different primary and secondary users with minimization of noise variance. The second objective is to design energy optimization through peak detection for spectrum sensing under different relay fading noise channels. The third one is to design and study artificial intelligence-based sensing of a spectrum for primary users. And the fourth one is to design and study the cognitive radio based sensing of a spectrum communication using hybrid network coding techniques for secondary users. That is the implementation of second and third objectives. And the final objective is to develop an efficient and high performance spectrum sensing and bandwidth sharing among primary and secondary users for effective sharing of data using hybrid cognitive radio network coding techniques and minimization of signal to noise ratio and PSNR values. These are the 5 objectives of my total research area. The motivation of my research is the radio frequency spectrum is it is natural resource, it is scarce natural resource, but and it is important in for wireless systems. But the demand in future is increases. The number of customers are increases. The demand is increases. But the frequency spectrum resources are very limited. In sometimes there are some frequency bands in the frequency spectrum should be free. At that time, the new investigation, the technique is called cognitive radio concept is coming. Here in this nothing but whenever the spectrum is free at that time, the unlicensed user enter your network and use the particular spectrum band for a temporary basis. Once it is completed and return to the original network. That is the concept of CR. Here this CR standards and activities are how spectrum occupancy and how we can spectrum sensing, all that done specific standard activities are CR done by ITUR. In future, availability of the spectrum holes can be predicted. Here, the spectrum holes are nothing but the frequency spectrum is free, nothing but frequency spectrum, nothing but spectrum hole. And in future, it is the intelligent channel selection whenever it is free or not, we have to calculate. This is the motivation of my research. And these are contents I would like to explain. Abstract, introduction, cognitive radio, introduction, literature review, spectrum sensing techniques, and what are the existing methods for spectrum sensing, what are the drawbacks, and what are the proposed approaches for spectrum sensing. Next, advantages, results, and conclusions, and future scope, and references and achievements. Abstract. The demand for spectrum sensing is rising day to day. The number of customers are increases, but the spectrum is very low. At that time, the new scheme is entered, is known as spectrum sensing. Here in the spectrum sensing, which is a thing, but the primary users' presence are not, we have to check. The primary user are nothing but licensed users. Here the device is called cognitive radio. Here in this, the spectrum sensing process involves gathering the signal features from the spectrum, and based upon, you have to set the threshold value, based upon the threshold value, whether the primary user present or not. That is, the primary user can use it using the spectrum or not. We have to check. This technique we are using for the spectrum sensing, number of methods are there, and energy detection method, matched filter technique, correlation technique, different methods are there. But these methods are only useful for, we have to check the spectrum sensing under signal presence only. But if noise is present in that signal, it is not possible. That's why we are going for, can use different peak detection energy techniques and deep learning techniques. We have to check whether the primary is present or not under noise also. For this entire process, I am getting accuracy is 99.9% and a probability of detection which is equal to 1 with low PSNR values. Introduction. Here, day-to-day wireless systems offering many variety of high data rate applications. That is, we are in 5G. Nothing but where different applications, the speed should be increased. In order to realize this objective, that they have to overcome the practical constraints imposed by the resources they need, such as power and spectrum. That is, it is limited. That's why we are going for the cognitive radio concept. Here in this cognitive radio concept, we had discussed 2 types of users, primary user and secondary user. The primary user, nothing but licensed user, which is used primarily to the spectrum. The secondary user, nothing but do have license to use spectrum, but can use the spectrum when PU is absent. Nothing but whenever primary user absent, then secondary user enter into network and use the frequency spectrum whenever the frequency spectrum holes are present. Here, what exactly the meaning of what is the definition of cognitive radio? Cognitive radio is a wireless communication device that can intelligently detect the unused spectrum in the communication channels and made it possible for the secondary users to utilize unused spectrum without interference with the primary users. Maybe there are two characteristics of the cognitive radio: cognitive capability and reconfigurability. The cognitive capability means to sense the information from the radio environment. Reconfigurability, based upon the information from cognitive capability, that rearrange the network. This based upon these two characteristics, cognitive radio having 4 functions, that is spectrum sensing, spectrum management, spectrum mobility, spectrum sharing. Yet the spectrum sensing is nothing but cognitive radio continues to check the frequency spectrum, whether is there any spectrum hole is there. Spectrum hole is nothing but free of the spectrum. This is called spectrum sensing. Spectrum management, when the spectrum holes are found in a spectrum, by using cognitive radio, select available hole or channel. That is spectrum management. Spectrum sharing, the cognitive, once the select the available hole or channel, the spectrum you can use the primary user, secondary user enter into network and utilize for temporary basis. That is spectrum sharing. Spectrum mobility, once the primary user is detected in the network, and automatically you can leave the particular hole or channel. That is spectrum mobility. These are the 4 functions of the cognitive radio. Here, this is the picture which shows the best example of cognitive radio architecture. Here, in this contains the unlicensed band, licensed band 2, like this. Here, the licensed band something, but we can, before using the network, we can take permission from the particular government agency or authority. Unlicensed band, anything but ISM band, industrial scientific medical band, there is no need to take any permission. Just like the best examples of Bluetooth is unlicensed band. Whenever the primary users in this network absent, then automatically the secondary is enter into network and use temporary basis. These are applications of cognitive radio which can use future wireless cellular networks, public safety systems, wireless medical networks, smart grids. Literature review. I will show you some of only basic important titles and authors which I am taking. Title is High Efficiency FCME based noise power estimation for long term and wide band spectrum measurements. And this can be this title and explained by the researcher is Iwata H et al. In the year of 2021. Likewise, different titles, different researchers I am taking for consideration to implement my proposed methods. And this slide shows what is the title and research names and year, the publications and techniques, and what is the advantages, what is the problems. Now I will go to explain what are the different spectrum sensing techniques are available initially. The first technique which are used for spectrum sensing technique is autocorrelation technique. Here in this autocorrelation techniques, we have to take few samples from the received signal. That is, from the received signal, that is, we have to take some of the features of a signal from the spectrum and receive the signal. From the received signal, we have to take only few samples and correlate with each other with lag 0 and lag 1 conditions with a time shifted version. After performing the correlation to obtain result compared with static threshold, that is, we have to fix one threshold value. If the output after performing the correlation, the output is greater than the static threshold value, greater than, higher than, then primary is existed. Then automatically we are not the secondary is not enter into the network. If the result is lower than the threshold value, then automatically the primary user offset, then automatically the secondary user enter into a network and utilize temporary basis. But this technique required more number of samples, but it is unpractical and complex. The second technique is matched filter technique. Here in this matched filter technique clearly explains the basics of a signal structure. In this process, we have to take received signal samples and convolve with previously stored information about primary user and average with number of n number of samples. Finally, we have to go for detection of a signal. With this result, we have to find a probability of detection. But in this technique requires far more information, that we want previously stored information required for convolving. So this is also fails. And different algorithms are there for based upon the energy detection techniques. In the year of 2016, A. Ranjan et al. Proposed energy detection method based upon the signal threshold based upon static threshold value. In this technique, they are used, the type of modulation technique is BPSK, QPSK, QAM like under AWGN. But this method shows poor results with low SNR values. In the year of 2015, P. Pandey et al. Checked their energy detection technique under NICE, also with the M cooperative schemes. But this technique cannot explain the signal present or not. Likewise, different algorithms are there. Instead of static threshold, we have to go for dynamically. You have to select the threshold value. Under this dynamic selection of threshold value, discrete Fourier transform filter bank method as there explained by the Deepak R. Joshi et al. They adopted the discrete Fourier transform technique to identify the threshold value. But this is method also fails to estimate SNR value. Another method is image binarization technique explained by the Prashop R. Nair et al. In the year of 2020 projected the chance of the threshold. We have to set the threshold value by using optimized detection parameters, especially probability of detection and probability of false alarm. Likewise, probability of detection under false alarm explained by the M. Sarkar in the year of 2015. And double threshold cognitive assist explained the Jimbo Wu et al. In the year of 2015. But all these constant false alarm rate methods and hybrid energy detection and RLRT method, all the different methods are there to find whether the primary user present or not. But all these methods are fails because if the signal contains noise, these are the fails, and we get some constant false alarm rate increases, false alarms. So, and now I would explain my base paper, the existing method for spectrum sensing. Here in the existing method is spectrum sensing through dynamic threshold selection via noise variance. Under noise, how to sense the spectrum by using dynamic threshold value. In order to overcome different existing methods under noise environment, introduce a new technique is dynamic selection threshold algorithm. In this method, the threshold is considered dynamically based on the noise degree. To calculate this noise stage, the powers of the transmitted signal and the noise signal is anticipated from the received signal without requirement of the previous facts. Just have to predict based upon the eigenvalues of the covariance matrix of a received signal. That is, this total method is depends upon the eigenvalues of the covariance matrix. Suppose I have to take the available bandwidth is capital B. Under the total capital B, we are occupied only the bandwidth is small b within this sample covariance matrix of a eigenvalues. Under this small b bandwidth, the range we have to assume that 1 to L. The range, the bandwidth is from 1 to L. Under this 1 to L, 1 to K considered a transmitter signal. The remaining from K to L is the noise signal. From these values, the value of K can be estimated with the using equation. After estimating the value of K, the covariance matrix eigenvalues should be calculated. Based upon the eigenvalues, the noise variance should be measured. To calculate the value of K and eigenvalues, based on eigenvalues, you have to calculate noise variance. The advantages: do not require any pre-information, likewise previous method. Using dynamic threshold values, you have to check. Reduce the probability of false alarm, shorten the sensing time. But disadvantages are there. The use of a static limit degrades the power detection efficiency. In this, the primary user's presence is decided based upon two stages. And require large number of samples. And prospect exposure is less. It takes more power consumption. The signal strength is low. And advanced knowledge of some primary user signals uniqueness. These are some of the disadvantages. So that's why we are going for the new proposed techniques. That is the proposed methods for spectrum sensing. The proposed method 1 is energy detection of spectrum based on peak detection approach. Energy detection of a spectrum based on peak detection approach under relay fading noise environment. Under relay fading noise environment. Why you have to choose only relay fading noise environment? Why not AWGN? Why not Ricin? Nothing but in AWGN and Ricin methods which are used only for the signal line of sight path and ground lifted path. We have to take only two paths, but under relay fading noise environment, we have to check number of multiple paths. We have to consider. That's why I have to take relay fading. Here in this method, peak detection is the main process. That is, in this method, pre-processing was carried using filtering techniques such as windowing technique as well as wavelet-based methods. Here, peak shows major occurrences such as sudden signal increase, sharp rise in amplitude, information burst, etc. This algorithm detects the peaks, nothing but the average amplitude of maximum signal in different settings. And this method includes as local maxima will found for signal portion exceeding the threshold value. Here, this figure exactly shows waveforms explain the peak detection process. Here, the first left side of the figure shows the times in seconds from 0 to 5 seconds and amplitude from in between 3 to -3 and detect the signal peaks. Now, I have to check from 4 to 5 seconds to show the detected peaks. What is the amplitude, maximum amplitude of a signal? One of the wide filter profiler methods are assumed to calculate the peaks of a signal. How to optimize a peak detection? Nothing but once you have to find out the peaks, peak amplitudes of a signal. Now we are going for optimization process. Here, the optimizing of a signal or power is the process of obtaining the best values or features from the initial values. This may be reduce the power consumption, it may reduce sensing time. That's why we are going for optimization. What is the methodology for this optimization? Here the energy is viewed and is assessed with a dynamic limit to amplify the possibility of exposure or relay fading in place. And relay fading is sensible when the several objects are present in the environment of radio signal before it reaches to the receiver. In this, the mean and phase of a signal mean should be 0 and the phase should be in between 0 to 2 pi radians. And based upon this methodology, this equation shows under relay fading noise and how to calculate power and how to calculate K value. And based upon the K value, we have to calculate what is the optimization signal from these equations. Right here, suppose I have to take AWGN setting. The AWGN setting, what is the difference between AWGN and relay fading here? Relay fading channels are used where there is no line of sight path also. But AWGN we have to consider line of sight path and ground affected path. For multiple paths, we have to take the features. We have to go for relay fading noise. Here we have to use the type of modulation which is PSK. Why PSK? Nothing but this is used for different application purpose like biometric, contactless activities, and RFID, Bluetooth communication, wireless LANs. That's why we are using PSK. Here now I am explaining how to implement the proposed method 1, that is a peak detection based energy detection under relay noise environment. Here I am taking total 1000 samples. Instead of taking input is 1000 samples, first I have to take packet wise. The input data packet size is 100. Now they take the data and apply PSK modulation and IFFT. The output of the is optimized data. Now I have to calculate power. Likewise, the total 1000 samples, that is number of packets are 10 packets. Likewise, I have to calculate power calculation. After power calculation, we have to calculate the minimum power from all the 10 packets and performance analysis and comparison of the probability of a detection. This is the implementation procedure. Like see this is that is the explanation. Input data assumed to be given parameters and apply phase shift keying. By only phase shift keying nothing, but it is widely used for wireless LANs, biometrics, contactless operations, along with RFID and Bluetooth communications. And apply IFFT, we are getting optimized signal. Likewise, for all samples, we have to calculate. These algorithms, we have to input is thousands symbols. From the 1000 symbol from the sector, output is probability of detection. The first step is we have to take the symbols like x1 to x1000. This can be divided into 100 symbols considered should be one packet. It is upon the T1, T2, T10, and we have to calculate a phase shift keying by using the formula. After calculating the phase shift keying output, apply to IFFT, then calculate the power for the IFFT output, then calculate peak values of the detect using formula. The second step is optimizing the input signal calculating power. Likewise, you have to take all 10 packets, calculate optimized data from the single formula, where k is distance between symbols. Next, the third step and final step is energy of the signal is calculated and the probability of detection is estimated. Energy of the signal is calculated and probability estimation. That is energy of the signal calculated by using this formula. And after this calculated, we have to compare with the dynamic threshold value. Based on threshold value, we have to check the probability of detection. The probability of detection, that is number of detection divided by number of trials. Based upon this algorithm and implementation, here this is the figure results shows of proposed method 1. We are taking x-axis frequency in terms of hedges and y-axis power in terms of dB per hedge. Here this is the first packet representation. This is the first packet representation with a 100 samples. Now, based upon this, we have to calculate optimizing the data. Optimizing the data. Likewise, second packet. Here in this, see this was here in this figure, the second packet having 100 samples. The power values ranges in between 0.2 to 0.59, but the optimizing data is 0.43. Instead of taking range, total range from 0.2 to 0.59, we have to take average. Then we have to put optimized data, which is equal to 0.43. Likewise, the third packet is 0.39 is optimized data, and fourth packet, fifth packet, likewise, all 10 packets. Once you have to calculate the optimized data ranges, we have to check the power of initial data. Now we have to draw the power for initial data, like frequency in x-axis for and y-axis we have to take power in dB per hedges. The power shows in the figure extended up to 10.5 dB per hedges. Now after this one we have to calculate optimization for this power also. Now we have to calculate power calculated from optimized data. Now we are taking instead of 10.5, we are now the optimizing, we are getting 9.5 dB per hedges. Based upon this optimization ticket, automatically the power consumption should be less and sensing time also should be less. After that one, we have to calculate performance analysis of normalized and optimized data. What is the before optimization, after optimization? Here, this blue line shows normalized and pink line shows optimized. We are taking x-axis is signal to noise ratio and y-axis is total power. Here, you see the difference between the normalized and optimized. Difference is 2 dB we are getting. Then automatically we had reduced to 2 dB. And this figure exactly shows the probability of detection versus signal to noise ratio in terms of dB with false alarm rate is 10%. Likewise, this figure shows under different channels, under AWG channels and different SNR values. Suppose if false alarm rate is 10%, the probability of detection corresponding to the sensing technique with the dynamic threshold reaches to 100%. That is, the probability of detection should be equal to 1. Then only we have to, it is the spectrum sensing is good or not. Whenever it reaches to 100% or probability of detection which is equal to 1 with SNR which is equal to 1 dB. This is a general technique without optimization. And static, we are using static threshold value for SNR equal to 4 dB under AWGN. But we have to assume that the channel is relay fading and probability of detection which reaches to 100% R which is equal to 1 when SNR is minus 3 dB. And the probability of detection based on peak detection reaches to 100% at SNR equal to minus 5 dB. Here we have to this figure exactly compare the different different SNR values. It reaches to 100% of the probability of detection with the dynamic threshold value or static threshold value or relay fading, under relay fading or optimization process. In optimization process, it reaches to 100% of the probability of detection under SNR which is equal to minus 5 dB. Here, this is exactly comparison between the optimization feature selection algorithm with previous spectral sensings. Now I'm taking the parameters like accuracy and probability of a detection with low SNR value and probability of the false alarm rate and mean square error and sensing time in terms of milliseconds. Likewise, previous techniques like autocorrelation based sensing technique, matched filter detection, noise estimation spectrum sensing, and relay fading. And finally optimizer feature selection algorithm. Compared with previous methods, the accuracy of optimizer feature selection algorithm is we are getting 98.6 compared with previous. That almost it is increases. It reaches to 98.6, and the probability of detection which is equal to 0.95, and the probability of false alarm rate is 0.77. That is the probability of false alarm rate is decreases. And mean square is 1.22 and sensing time is 25 milliseconds. With very less time it sensed whether the primary user present or not. These are some of the advantages we are getting based upon the peak optimization process. Now here in this, accuracy is 98.6 and probability of detection which is equal to 0.95. We want the probability of detection should be equal to 1. Then only the technique is perfectly good. That's why we are going for some advantages are there for this technique, that is the potential of increased exposure and less energy needed for the method, and power consumption should be less. And what is disadvantage? Difficult to develop, and these methods are complex, and accuracy and probability detections are not almost equal to 1. So that is the disadvantages, and bit error rate is high. That's why we are going for next method is the proposed method 2. That is, we have to implementing this spectrum sensing technique by using deep learning process. That is, design of novel artificial intelligence architecture for sensing the primary user in the spectrum. Design of novel artificial intelligence architecture for sensing the primary user in the spectrum. Here the proposed method by using a deep learning method. Here, what exactly the deep learning process? What is the architecture of deep learning architecture? Here, it contains a sequence input layer, LSTM layer, ReLU layer, 3 fully connected layer, softmax and classification layers. These are 5 layers in the proposed deep learning architecture. Here, what exactly means the sequence input layer? This is the first layer in the architecture, and followed the remaining layers. In this input layer, what are the inputs of what are the input signal features we have to give? After that, we have to connect it to LSTM layer. The LSTM layer is nothing but long short-term memory layer. Long short-term recurring layer. What is the use of this LSTM layer? It is used to training an order data taken from sequence layer. Just you have to take and order it. That is the use of LSTM layer. Here in this LSTM layer, the total data can be divided to small cells. Instead of sending the total information, I have to go for into small cells and give it to the ReLU layer. Here the ReLU layer, nothing but we can ordering the cells. Next one is fully connected layer. Here the fully connected layer, nothing but the data derived from the previous layer. That is LSTM and ReLU layer. The data derived from the previous layers are multiplied with weight matrix. Multiplied with by weight matrix formed by a fully connected layer. And the vector of bias is applied. This layer consists of one layer or more than one layer. Likewise, all the neurons in this layer, as the name indicates, interact with all features obtained by the previous layer. Next one, the output of the fully connected layer is given to softmax and classification layer. Here, what is the use of the softmax layer? The softmax layer is often referred to as exponential normalizer. Exponential normalizer, and logistic sigmoid function can also be regarded as a multi-class generalization. Multi-class generalization. Here, the classification layer must be activated for the traditional classification of networks. This is the general brief introduction for the deep learning process architecture. From this, now I have to implement the proposed method 2, that is the proposed methodology of a spectrum sensing for detecting the user presence using a deep learning process. This is the block diagram of proposed method 2 under deep learning process. Here in this, we have to take the previous method also. That is, we have to take the input is random signal. From this random signal, we have to calculate first power optimization features first. That is likewise previous proposed method 1, power optimized features. Once you have to calculate power optimized feature, it reaches. And parallelly, we have to calculate the entropy features of a random signal. From these entropy features, we have to train the network with features. Once we are getting the entropy features and power optimized features, we have to form a hybrid test network. Form a hybrid test network. This is about objective 4. That is hybrid. Hybrid is what? Both of the entropy features and power optimized features. From this hybrid features network, we have to detect whether the primary user present or not. For this, after detecting the user present, we have to calculate the histogram for the two hypotheses. Histogram calculation. After that, we have to display the graph. Here, the procedure is like we have to implement hybrid network. That is the first from power optimization features. That is the signal taken from the spectrum is optimized using the previous optimization algorithm. These optimizations were taken into features. These features are saved in .mat files. .mat files it contains both signal plus noise features. These mat files are trained using deep learning techniques like convolution linear network. Similarly, you have to calculate entropy features. Here, the entropy is nothing but it's a randomness in the signal, which will give the information about the noise coefficient and signal coefficient, which gives the information both noise and signal coefficient. And this entropy explains the statistical properties of the signal obtained from the spectrum. From these both power optimization entropy features, now we are going for the algorithm. This is algorithm just like a previous peak detection method also. Here the input also 100 symbols. Output is accuracy and loss calculation should be estimate. The first step, like we have to take 1000 samples. Represent x1, x2 up to x100. It divided into 10 packets. For each packet, we have to calculate, apply the phase shift key. After phase shift keying applying, we have to apply inverse fast Fourier transform. After that, we have to calculate the power from the IFFT output. Likewise, you have to calculate for all 10 packets. Next, second step is assumption of hypothesis. Assumption of hypothesis for the presence and absence of user and calculation of entropy. Presence and absence of user and calculation of entropy. Here in this hypothesis, I think but we have to B0 and B1. What is meant by B0? Nothing but for the absence of primary users. B1 for the presence of primary user. What is this? The specifications B0 and B1. B0 we are getting B0 nothing but the primary user offset. So the second is entry network. Likewise B1 for the presence of the primary user. Now we have to calculate the entropy for this one. Once we have to calculate the entropy. Now I have to go for the third step is training and testing of LSTM network for the spectrum sensing. That is we have two features of the saved.mat files, extension with both B0 and B1. And these files, mat files, are used for training LSTM network. Finally, the network test features, the combination of optimized features and entropy features. Based upon this combination, the dialog box can be present whether the user presents or not. Finally, we have to calculate the probability of detection and probability of false alarm. The probability of detection nothing but number of detections divided by number of trials. And the probability of false alarm calculated number of active detections divided by number of inactive detections. Based upon this algorithm, now I'm explaining the results. Here we have to take two cases. First, I have to take the case 1, A equal to 1. A equal to 1, case A. Here it shows the accuracy and loss. Accuracy and loss. In this, whenever A equal to 1, here you have to take x-axis is iterations and y-axis is accuracy. Similarly, for loss calculation, x-axis is iterations and loss in the y-axis. Here in this, whenever the user selects the input value A equal to 1, input value A equal to 1, the accuracy with less number of iterations suddenly increases and reaches to 100% with less loss. Then automatically the dialog box shows the primary is absent. Nothing but the secondary user entered into a network and use the temporary basis. Based upon these dialog boxes, we have to generate histogram. Here histogram, here two figures are there. Histogram of a spectrum, data without user presence, and histogram of spectrum data with user presence. See this one figure 24, the histogram of spectrum sensing without user presence. Without user presence. See this one, very less chance are occupied. Very less chance are occupied. Here you have to take consideration of AWG and noise. Here, the number of holes are more. Whenever the histogram of a spectrum data with user presence, maximum the it is occupied. Here, this is the figure actually shows the comparison graph between signal to noise ratio with average interference, that is entropy. X-axis we have to take SNR value and y-axis take entropy. Here, entropy is nothing but it is randomness of the data. It is considered one of the features of the spectrum sensing. That is, we have to calculate the coefficients of signal and noise. Here, this graph resembles the entropy values of the data, the presence of a user with low compared entropy values in the absence of user. These blue holes are shows a spectrum with noise. The pink color shows spectrum with signal and noise. In case 2, if I have to select A input value A equal to 2, the accuracy, see the graph, the training process, figure number 27. The number of iterations x-axis we have to take and y-axis we have to take accuracy and loss. Whenever A equal to 2, the accuracy is reached to 100% is more than the previous method. It takes more iterations to calculate whether the user present or not. And loss only is slightly decreases. Based upon this graph, the dialog box shows spectrums. So
Yes.
we are
Yes, Sunil, you just focus on what is meant by A. What is the significance of value A equal to 1 and A equal to 2?
okay, sir. Okay, sir. Okay, sir. Here in this approach, I'm taking two switching cases. Two switching cases. Here, A equal to 1. A equal to 1, nothing but A equal to nothing but whether with the less number of iterations, we have to give A. Here, the A is nothing but what is the exactly the accuracy value. Whenever the accuracy equal to 1, A equal to 1, and accuracy A equal to 2, and whenever accuracy equal to 1, nothing but with less number of iterations, we are getting more number of spectrum holes are available, then automatically the accuracy should be reaches to 100%. Likewise, switch cases, you have to take case 1, case 2 like this. A nothing but cases. In case 2, I had assumed that A equal to 2, A nothing but case 2, like accuracy, just I am taking, it is A equal to 1, A equal to nothing, but just like switch cases. A equal to 1, what happened? A equal to 2, what happened? If A equal to 2, nothing but the spectrum is equipped with the user, the primary user present, so then automatically the secondary user is unable to enter into network. Then automatically the dialog box shows the primary user is accessing the spectrum. By considering these results from A equal to 1, it reaches to accuracy with less number of iterations, 99.9%, and probability of detection which is equal to 1 with low signal to noise ratio value. From this, now the table 2 comparison with signal to noise ratio at minus 5 dB. Likewise, in previous methods we have to compare. By using this deep learning method, the accuracy is percentage 99.9%, and probability of detection at low SNR value is 1. It reaches to 1, and probability of false negative decreases. In previous proposed method 1, we are getting 0.77. Before that one, under relay fading, where I am checked with the base paper, 0.85 we are getting. But now by using deep learning method, the probability of false alarm is decreases 0.65, and the mean square error is 0.4, and the sensing time is reached to we can use the commercial use process, and we can use in military applications and in hospitals and smart grids, different areas we can use these proposed methods. Here, up to this one, the spectrum, how to spectrum sensing is okay, but what are the problems occurs? Why? Because the spectrum is under government agency, that we have to take permission before using. But what are the problems occurs in real-time applications? The first one is primary user emulation attack. Primary user emulation attack. Here nothing but blocking. Suppose we have to take jammers. What is the principle of jammers is interrupt the infrastructures. Whenever the jammers are found, then automatically we are not implemented, and it prevents the cognitive radio concept. Jammer attacks. Is success is smaller. Attacks, we are getting more. And automatically the cognitive data concept can be implemented whenever jammers are present. Likewise, different countermeasures are in cognitive data networks. The countermeasures for primary user emulation assaults can be divided into 4 categories: channel hopping, radio fingerprinting, cryptographic approaches, location based. These are the 4 countermeasures. Channel hopping. The channel hopping is earlier mentioned, like avoiding the primary user emulation. That is in cognitive. Whenever we have to implement this in mobile networks, where frequently handoffs are present. When handoffs are present, automatically we are not implementing this CR network concepts. Radio fingerprinting and cryptography approaches are there. That is the cryptographic signatures in a primary user signals, as well as the usage of security and authentication methods. And location based. These are the 4 countermeasures in cognitive networks. And attackers. If you implement cognitive concept, in sometimes attackers are entering networks and collapse the total network issues, and they can change the algorithms concepts. Now, what are the most important security needs required for these cognitive radio concepts or software-defined radios? The threat is hazards software is installed, security integrity. Information tampering or deletion is integrity. Software modification or deletion is integrity. Retrieval of information, confidentiality. These are main threats in the cognitive radio networks, or it is called as software-defined radios. Finally, I conclude of my research. Hence, these proposed methods are implemented based upon the power optimization features and entropy features and form a hybrid network and using this LSTM-based deep learning architecture. And this process helps to derive the spectrum status, whether the primary is present or not. With the accuracy and probability of detection, the final we are getting the accuracy is 99.9% with LSTM-based deep learning architecture, with a probability of detection which is equal to 1 at low PSNR values. Here in future, we can implement D2D communications along with spectrum sensing to enhance the network architecture from mono to hetero. And we can use this SDR or cognitive radio management, which you can use in future LTE, advanced networks. And we can implement in MIMO techniques and multiple radio access technologies, dynamic co-channel adjacent channel interference mitigations, non-continuous carrier aggregations, coordinated multiple point transmission and reception, and different applications we can use this type of cognitive radio concepts. And finally, references. These are the references I checked. Based on these references, I implemented my proposed methods. Finally, achievements. In my publication part, I published one SCA paper in Springer and two Scopus papers and one a novel artificial intelligence architecture for sensing the primary user in the spectrum is under review in Springer journal. And my patent is published. That is the first proposed method, the peak detection based energy detection of a spectrum and relay fading noise environment in the October 1, 2021 with application ID 2021-4104-1465. Patent is published. Now I'm going for granting. And I'm attended 6 international conference within the nation and international. And I attended one national conference. And I done 3 courses related to my research and FDPs, workshops, webinars. And till now, yesterday, the citations, SCA paper got 2 citations, and Scopus citations are the total 3 citations. Again, any comments?
Yes, Sunil.
Yes, sir.
Yes, you have presented your work nicely.
Okay, sir.
Very good presentation. I have seen your presentation. I have seen your thesis also, and I know you have made all the incorporations whatever have been told and have been given to you for during the evaluation process.
Okay, sir.
And I hope that you have incorporated also all the grammatical and typographical errors in the thesis.
Okay, sir.
And today you have presented your work. It's nicely presented again, and just repeating the same thing.
Okay, sir.
I don't have any technical kind of questions now.
Okay, sir.
It has already been told. And just I would like to ask a few general questions. How much your thesis is is relevant in the practical scenario? Your work is how much relevant it is?
Yes.
How can you just justify this that this is innovative one and having means novel features in your work.
Yes, sir.
Sunil?
Sir, madam.
Sir asking in what way your project will be novelty and how we can implement, like sir asking. Everything okay, fine. You
Okay.
adapted everything nicely, sir says likewise. Sir asking for small queries.
Uh, can you implement through GUI, sir?
You can implement it with how? Please just elaborate.
Suppose in mobile communication, the frequency were allotted to government agency. Suppose in a particular, suppose I had to go for rural area. Suppose based upon the fixed channel assignment concept. But suppose in that particular area, the number of users are less, and the frequency spectrum sometimes is waste. At that time, we have to apply these algorithms, and whenever it is the frequency is wasted, the particular frequency we have to take temporarily and utilize.
Okay. In objective 2, the spectral sensing through peak detection process. So, what kind of signal you have taken for peak detection?
Random signals, sir.
Which signal? It is the means primary user signal or means whatever the kind of signal you have taken.
Just to take the signal features from the received signal, sir. Just take the signal features from the spectrum sensing. Signal features.
Yes. Okay. That's all from my side. Please, I just now want to means allow the audience, please, if any one of you if they would like to ask any questions from just feel free.
Sir, Ashraf sir?
Yes, madam.
Yes, sir. If you have it.
Yes, am I audible?
Yes, sir. Audible,
yes, sir.
Okay, Sunil. Okay, so Sunil, thank you for your nice presentation.
Thank you, sir.
You have in your thesis, you have tried to fulfill. Your work was to fulfill 5 objectives, as you have mentioned in the presentation.
Yes, sir.
And the work for the spectrum sensing, already the existing approaches are there: autocorrelation based energy detection,
yes, sir.
and then the match filter based techniques, where you have given the importance for threshold detection.
Yes, sir.
And by combining the existing methods and your modification, you have improved the spectrum sensing methodology. Okay, in terms of probability of detection, match filter, and the false alarm probability. Okay, and you have published one SCI to Scopus. Also, you have filed one. You have published one patents also. So work is good, and it is worthy of your PhD degree. I have one or two few comments are there. Can you go to the slide number 45? Slide number 45. Yes, 45. So here in the y-axis, just little bit modification. I think it is you have written power in dB per hertz, no?
Yes, sir.
So I think it is power spectral density, and unit may be dBm per hertz. I think dBm, no?
Yes, sir.
Instead of dB, it will be dBm. I think dB milliwatt. I think.
Yes, sir. Yes, sir. Yes, sir.
Okay, that is one correction. I think.
Okay, sir. Okay, sir.
This is for the next slides where you also give the similar type of.
Okay, sir. Thank you.
Okay. And another kind of thing is just little modification. 65 slide number 65. If you go, $65.
Yes,
next,
sir. 65.
Next. No, equation is there. No, this is 64. I think.
Yes, sir. It shows 66. Sir.
Oh, but 65 was there. That one equation was there. This one. No, this one. Here in the where TB bit period and EB is symbols, na?
Yes, sir.
But EV is the average beat energy for the or average symbol energy, I think. Huh?
Okay, yes, sir.
EV is the
I will
energy.
check. I will check,
Hmm.
sir. Once again, I will check, sir.
Okay. So my from already you have addressed the comments from the Indian examiner and the
Yes, sir.
comment,
Yes, sir.
and there was no such comments from the foreign examiner.
Yeah, no,
Okay.
sir. Yes, sir.
So hope you have incorporated all the comments in your modified version of the thesis.
Yes, sir.
Yes, sir.
Yeah, modified, sir. Modified, sir.
So I have one query only. In your work, you have considered the rally fading environment, na?
Yes, sir.
One of the method. Why you have not considered the other environment like the Raysian fading environment?
Why? Because relay fading, which is used for multipath, have take signal features from multipaths, sir. But remaining fading, we are getting we have to take line of set path and ground reflector paths.
Okay. ठीक है, okay, thank you.
Thank
From
you,
my
sir.
side, it is over. Okay.
Thank you, sir.
So thank you, sir. Thank you, sir. Sir Surendra, sir.
Yeah, ma'am, please.
Yes, sir. Can you please announce officially announce Sai Sunil, sir? The,
Yeah, please say it again, please.
sir, actually, I invite you to announce Sai Sunil to turn as a doctorate, sir, officially.
Yeah. There is no other one. Any other from the audience, if they would like to ask any question first.
Any questions from audience, please?
So I think it's okay from all the sides. So I think as Doctor has also already announced that his work is very nice. He has already presented one SCI and two focus signal. And very important thing is that he has also filed one patent. Congratulations to Sai Sunil and to
Thank you, sir.
Madam Kamala
Thank you,
both
sir.
from my side. And I hereby announce that he has passed his examination of this PhD doctorate examination, and I declared that he has cleared his examination, and his degree must be awarded. His degree must be awarded to Mr. Saitni. Congratulations to Sain and congratulations to your supervisor, Mr. Siamola, also
Thank you,
for
sir. Thank you,
presenting this
sir.
very nice work.
Thank you, sir.
Thank you, sir.
Okay. Congratulations, Sunil, and
Thank you, sir.
congratulations to supervisor.
Thank you, sir.
Thank you, sir. Thank you very much, sir. Thank you, sir.
Thank you, sir.
Thank you,
So,
Surinder sir, for your evaluation. You have spent
Thank you, sir.
a lot of
Thank you, sir.
time.
Thank you, sir. Thank you, sir. Thank you, sir.
Yes.
I'm very much thankful for giving me a chance to evaluate the thesis and to go through this complete process. I'm always be ready to be there at your institute if you give me a chance. And because now this the process starts online, it is also okay. But if I got a chance, I will definitely visit your campus also.
thank you very much, sir. I hope hereafter in the forthcoming years also we have to join together, sir. Thank you. Sunil,
Madam.
it's a right now it's a platform. Whatever you want, you can share your views. Just 1 minute.
Okay, madam. Thank you very much for attending my final public voice meeting. Thank you, Surendra Soni sir and Ashraf sir, and my RSC experts, Manikandan sir and Iqbal sir, and those who are participated in my voice, my colleagues and research scholars. And finally, I'm very thanks to my guide Shamla Madam, Professor in ECE, Weltech. She continuously encouraging me to encourage day to day progress and monthly progress and how to publish papers and each and every thing. She helped me a lot. He helped me a lot. Finally, I thank you, my guide, Shamla Madam. Thank you, one and all, those who are participated here. Thank you very much.
Okay, thank you, Sunil.
Thank you, madam.
Sir, thank you, Surinder sir. Dr. Ashraf sir, thank you very much, sir. I will make a call, sir.
Thank you. So
Yes,
Thank
sir.
Thank you.
Further
we can
process,
leave now, no?
yes, sir. Please, sir.
Okay.
Thank you very much, sir. Thank
thank
you.
you.
May I leave?